analysis. On this slide, I will teach you on how to do Buckingham pi theorem method. Okay, before I go, I explain about the Buckingham pi theorem. Let's take a look at steps for Buckingham pi theorem. There are 6 steps. Step number 1, list the parameters in the problem and count their total number n. And number 2, list the primary dimensions of each of the n parameters. Okay, number 3, set the reduction J as the number of primary dimensions. Calculate K, the expected number of pi's. According to Buckingham pi theorems, the expected number of pi's, okay, or K, is equal to n minus j, and the equation is K equal to n minus j. Number 4, choose j repeating parameters. So guideline on repeating parameters will be taught on another video, and I really hope that you will watch that video as to understand on how to choose your repeating parameters. And number 5, construct the case or pi's and manipulate as necessary. Last, number 6, write the final functional relationship and check algebra. Okay, let's take a look at the question. Force on propeller F depends on the following physical properties. First is diameter, d, and second, forward velocity of the propeller, okay, or velocity of the plane, u, and then third is fluid density, rho, fourth is revolutions per second, and number 5, fluid viscosity, mu. So in this question, asks you to show that F over rho u square d square is equivalent to, or is a function of, phi is a function, and d over u and mu over rho ud. So let's take a look at the first step. Okay, list the parameters in the problem and count their total number n. So let's me change to pen first, and then the color of the pen will be black. I will change the color. Okay, black. So we have to list all the parameters. Okay, now I will wrote that F, force on propeller, is a function of diameter, velocity, forward velocity or velocity on plane, and then density, revolutions per second, and dynamic viscosity. So let's count the total number of n. Okay, F is first parameters. Oh, sorry, not this one. D is second. Number 3, number 4, number 5, and number 6. Therefore, we have the total number of parameters is 6. Okay, 1, 2 is diameter, 3 is velocity, 4 is density, 5 is revolutions per second, and last is viscosity, number 6. So our total number n equal to 6. Okay, next. List the primary dimension of each of the n parameters. So let's take a look at one by one parameters. So parameters first is force. Okay, force F. Unit for F is, so here is unit. Okay, unit for F is kilogram meter per second square. This is unit for F. And then we change it to dimension. So dimension. So dimensions. So dimension for kilogram is mass. M times with dimension for meter is L. And then divided by dimension for second is T. Now T second is square, then T is square. Change into another form, so I will write like this. Sorry. So L T minus 2. Okay. So parameter number 2 is diameter. So diameter is D. And then let's take a look at the unit. Unit for diameter is meter. And then what about the dimensions? Meter, the dimensions is L. And number 3, forward velocity. So forward velocity is velocity, and unit for velocity is meter per second. And then meter is L, second is time. So we change into another form, LT minus 1. So number 4, fluid density. So density. So density is rho, and a unit for density is kilogram per meter cubic. So change into dimension. Kilogram is mass divided by meter is L to the power of 3. So change into another form, ml minus 3. So number 5 is revolution per second. Revolution per second, this is N. So N unit is revolution per second. But here we have 3 primary dimension, M, L, and T, and we do not have revolution dimension. Therefore, revolution would be changed into 1 per second only. Okay, we remove the revolution, it would be 1 over S, and then this change into dimensions, it would be 1 over T. And then change into another form, T minus 1. So last is viscosity. So viscosity, mu, unit is kilogram per meter dot second. And then we change into dimension, kilogram is M, and then divided by meter is L times with S is second is T. Change into another form, M L minus 1 T minus 1. Okay, therefore we already list all the primary we list the primary dimensions of each of the n parameters. Then what's next? Set the reduction J as the number of primary dimensions. Calculate K, the expected number of pi's. According to Buckingham pi theorem, the expected number of pi's is equal to minus n minus J. So let's take a look at the J number. Okay, J maximum that it can be is 3 and minimum is 1. So J represent a primary dimensions in your listed parameters. Let's take a look at the parameters. Okay, I change to red. Okay, we have here, we have M and then L and also T. Therefore, your J equal to 3. It doesn't matter where is your primary dimensions are. Maybe your primary dimension for M is at the first parameters, and second parameters will be L, and the last parameters will be T. It doesn't matter. What you need to do is you need to see all the parameters and count their total number of primary dimensions. Okay, your primary dimension is 3, therefore you must take a look at all the parameters. Let's say here your force have M, and then number 4 density have L, and then number 3, 6 you have time at these parameters. So total primary dimension in your listed parameters would be 3. Okay, you have to see all the parameters, not only one parameter. Okay, you have to see all the parameters and list the J numbers, or calculate, count their J numbers. J number 3 is represent M, L, and T. If you have these 3 primary dimensions, then your J value would be 3. If your J value is 2, then maybe you have only primary dimensions of M and L, or maybe M and T. And if you have J equal to 1, maybe you have M or L or T. Okay, and it is impossible for J numbers to be 1, because maybe 2 or 3. So here you have to take a look at all the dimensions for all parameters and then count the total number of primary dimensions. Okay, here we have 3 primary dimensions, M, L, and T. Okay, therefore your J numbers is 3. Okay, your J numbers is 3. So in your question, J number is 3. Previously, we already count for your total parameters. N is 6. Therefore, to find K, you have to minus N with J. So 6 minus with 3. Therefore, you will get 3. These 3 values represent pi's number. Okay, so if you have 3, therefore you have pi 1, pi 2, and pi 3. So this is reflects to the values of K that you calculated here. Okay, you have 3 pi's, pi 1, pi 2, and pi 3. Okay, choose J repeating parameters. At this point, you need to see the videos, my videos explain about the guideline on choosing repeating parameters. But in this question, it is slightly different because this question asks you to show that from this, we know that there are 3 pi's. So F number 1 is represent pi 1, this is pi 2, and this is pi 3. So you have 3 pi's here. So here pi 1 is F, and then rho ud is your repeating variables. Same as here, your revolution is N, D and U also have here D and U. Therefore D and U is confirmed to be your repeating variables. And then we take a look at the next dimensionless. Okay, mu over rho ud, and then we know that rho ud is the same as here, rho ud, and it is confirmed that rho ud is your repeating variables. Okay, for this question, sometimes repeating variables already been given in your question. Sometimes you have to choose. If you have to choose the repeating variables, please go to my videos on explaining on choosing repeating variables. But at this point, the repeating variables for this question is rho ud, because every of these pi's consists of rho ud, or consists of these parameters. Okay, this consists of rho u and d, and here is d over u, and here is rho ud, and it is confirmed that the repeating variables for this is equivalent to 3, and then the parameters are rho u and d. Okay, so j repeating variables, the number of repeating variables is the same as the number of j. Okay, now you know that j is 3, where we have dimensions m, dimension l, and dimension p. We have j equal to 3, therefore you have to choose repeating variables. Okay, repeating variables that is equal to 3. Number of repeating variables. So you have to choose repeating variables 1, repeating variables 2, and repeating variables 3. So in this question, we know that the repeating variables are rho, u, and d. Okay. So after you choose your repeating variables, you have to go back to this here, and I will change pen color to green. Okay, now you choose rho, u, and d. It will be excluded, and then you have 3 pi's, right? So where does this pi's from these parameters? So f would be your first pi. So pi 1, n would be your second pi, pi 2, and mu, viscosity, would be your third pi. So this is repeating variables, and then repeating variables will always repeat at every of the pi's, and you will see the form of this pi. Okay, I will show you after this. Okay, so force, n, and mu is your pi's. So let's take a look at this. Okay, construct the k or pi's value. We have 3 pi's, so I use green color. So we have pi 1. Okay. Okay. The form of pi is pi. So this is n. And then we have first box, and then second box. First box is for pi, and then second box is for repeating variables. Okay, let's take a look. Okay, we have 3 pi's. So pi 1 equal to, I've already told you that for pi 1 is force. So write down force. So we times with our repeating variables. Okay, repeating variables is rho, and then power with a, times with u, power with b, and then d power of C. Okay. Equal to, we know that we have three primary dimensions. So we have M, we have L, and we have T. So make the power of each of these dimensions to 0. So M to the power of 0, L to the power of 0, T to the power of 0. So that is your first pi. And second pi is revolution. So N, you times with, change the color. I already told you that repeating variables will repeat in every of pi. So here is rho to the power of A times with U to the power of B times with D power of C. Okay. So equal to M power of 0, L to the power of 0, T to the power of 0. And if your primary dimension for your question only have M and L, therefore here would be equal to M to the power of 0, L to the power of 0. It will not be M0, M to the power of 0, L to the power of 0, T to the power of 0. This is when your primary dimension in your listed parameters consists of these three primary dimensions. Okay? And then third pi, okay, the last pi would be viscosity times with, change pen color to green. That. So repeat again, rho to the power of A times U to the power of B times D to the power of C. Okay, equal to M power of 0, L to the power of 0, T to the power of 0. So this is the form of pi. Okay. So pi equal to, this is pi that I've mentioned before. So we cancel out variables that already been chosen as our repeating variables, and then the rest would be your pi. Okay. And we already cancel rho, U, and T because rho, U, and D will be repeat in every of the pi's. And then the front of this, the front parameters here will be replaced by all those unselected parameters before. Okay. Okay, let's take a look at the first pi's. Okay. We will calculate what is the value of A. Here we have A, B, and C. We want to find our objective here. We want to find what is the value of A, B, and C. Okay. So first is pi 1 equal to F rho A U B DC equal to M0 L0 D0. Okay, substitute dimensions for every of these these parameters. Okay, parameters dimension for F is M L T minus 2. So dimension for rho density is M L minus 3 power of A. And then dimension for U is L T minus 1 power of B. Dimension for diameter is L to the power of C and equal to M 0 L 0 T0. Okay. Next, check M. Okay, M. So M is power of 1, therefore we put it 1. And then second is M power of 1 times with A. So multiply will be plus A. Okay. Next, there is no M here, so we do not plus or minus B. And then same as here, no M, equal to, so M to the power of 0, so equal to 0. So A is minus 1. Okay, that is first, check on M. So we check on L. Okay, check on L. So we have L to the power of 1, 1. L power of minus 3 times with A would be minus 3A. So we plus, because this is multiplication, and then multiplied would be plus. So here is plus times with minus 3A. It will be minus 3A. So L. So here L is power of 1 times with B plus B. Okay. Here is L power of 1 times with C plus C equal to 0. We cannot solve this because there is two unknown here, B and C. Therefore, we move to check on T. Okay, we cannot solve it. Then we go to check on T. So T is minus 2, and then here there is no T. Here minus 1 times with B minus B. There is no T here, and equal to 0. Okay, T to the power of 0 equal to 0. So B is minus 2. Then we substitute value for B and value for A into this to get what is the value for C. So 1 minus 3 times with negative 1 plus minus 2 plus C equal to 0. Therefore, our C is equal to minus 2. After you get this A, B, and C, then you substitute back into this equation. So pi 1 equal to F times with rho to the power of minus 1, because rho is power A. And then U to the power of B. B is minus 2, then substitute minus 2. Then last is D. D is power of C. C is negative 2, and then it will be here is negative 2. Therefore, your pi 1 is F over rho U square D square. That is your first pi. Okay. Let's move to the second pi. Okay. Pi 2 is revolution times with rho power of A, U power of B, D power of C equal to M power of 0, L power of 0, T power of 0. Then substitute dimension. So dimension for N is T minus 1. So dimension for ML minus 3, power of A, LT minus 1, power of B, L power of C equal to m power of 0, l power of 0, t power of 0. Then check m. Here we have m power of 1 times with a is a. No m here, also here, and equal to 0. So equal to 0. So your m is 0. So check L. So there is no L here. Here L minus 3 times with A minus 3A. Okay. L here is 1 times with B plus D. Okay. L here is 1 times C plus C equal to 0. We cannot solve this yet because there are two unknown here. So we go to check T. Okay. T is minus 1. Okay, here no T. So here is minus 1 times with B. So it will be minus B. And then here there is no B. So equal to T to the power of 0. Equal to 0. So your B is equal to minus 1. So substitute the values of A and B into this equation. So negative 3 times with 0 plus minus 1 plus C equal to 0. So your C value is 1. So after you get these values, substitute inside this equation. So your pi 2 is equal to n rho to the power of A is 0, so rho power of 0, U is power of B is minus 1, and then D power of C is 1. Therefore, rho power of 0 is 1, therefore there will be no density terms in your pi 2. So it will be n d over u. So you already solved the second pi, and then we go to the next pi 3. So pi 3 is mu times with rho power of A, u power of B, d power of C equal to m power of 0, l to the power of 0, t power of 0. So substitute dimension. So dimension for mu is m, l minus 1, t minus 1. And then density is L, T, sorry, not LT. Density is M, L minus 3, power of A. Next is velocity LT minus 1, power of B. And L power of C equal to M0, L0, P0. Okay, check M. Check M. So M is 1. Okay. Here is plus A. Okay, 1 times with A is A. There is no M here. Also here no M, equal to 0. So A equal to minus 1. So check on L. So your L is minus 1, okay, minus 3 times with A minus 3A, and then L here 1 times with B plus B. Here is 1 times C plus C equal to 0. So we cannot solve this since there are two unknown here. Therefore, we check on T first. Check T. Okay. T is minus 1. And then here is minus 1 times with B minus B. No T here and equal to 0. So B is equal to minus 1. So substitute values for B and A into this equation. So minus 1 minus 3 minus 1 plus minus 1 plus C equal to 0. Your C value is minus 1. After you get this value, substitute inside pi 3 here. Okay. So pi 3 equal to, so mu rho to the power of A. A is minus 1. U to the power of B. B is minus 1. D to the power of C is negative 1. Therefore, your equation becomes mu over rho U D. Okay, that is your third pi. Okay, we already solved all the pi's, and then we go to the next step. Write the final functional relationships and check algebra. So your final relationship would be pi 1 equal to functions of pi 2 and pi 3. Or you might write in the form of pi 1 equal to phi pi 2 pi 3. So substitute all the pi's that we've already calculated before. So our first pi is f over rho q square d square equal to, because we want to show the equation is the same as in the question, therefore we use phi. So pi 2 is n d over u, and last pi 3 is mu over rho u d. So shown, we already shown that this pi is equal to what in the question asked us. Okay, that's all. Thank you.